So let's begin with a quick recap of what we have learned till now. You all know that we were discussing about the compilation process. If we write any program, how will that program be executed on the computer? Process we were seeing in a sequential flow format. So the first thing that comes is our source code. Our source code, since we are adopting C language as the high-level language, will be passed on to a component because source code cannot be understood by the computer. It is in English language, high-level language. It will be passed on to a component called as compiler. Compiler will try to take that source code, which is written in C language, called as prg.c, and this source code will be converted by the compiler into a assembly language code. This assembly level language code is not ones and zeros. It takes English language to pick up the most commonly used words in the operations and substitute those words with its mnemonics. Mnemonics are some nicknames given to commonly used combination of ones and zeros. So our target was to convert the source code into ones and zeros, which can be understood by the computer. But it cannot be converted directly into ones and zeros. It will be passed on to compiler. Compiler will convert it into an intermediary language, which is called as assembly level language. So our prg.c, which is a high level language program, will get converted into assembly level language program. Now with this assembly level language program, when it has to generate it, compiler will try to pick up those functionalities which we have defined, as well as it will try to substitute those functionalities which we are using from who has already defined. Some functionalities we will write, but some of the functionalities we'll try to make use of from the previous authors, from previous programmers. So already some programmers have written brilliant programs for us. We'll try to just use those programs in our C program instead of writing them again freshly. So those already written predefined programs will be written in preprocessor directives. So our source code, which we have written along with the preprocessor directives code, will be compiled by the compiler into a assembly level language code. This assembly level language code will be specific for a given computer. Suppose the computer is 64-bit computer. Assembly level language code will be for 64-bit understanding only. If the computer is 32-bit computer, the assembly code will be written for 32-bit configuration only. So that's why we call it as target assembly code. So again coming back, source code is given to the compiler. Compiler will take all the functionality which we have defined along with those functionalities which we are trying to use from already defined which is present in preprocessed directives. It will combine them, compile them, and then pass it as a assembly code. This assembly code is not completely ones and zeros. So again, it has to be converted from mnemonics to ones and zeros. So to convert it from mnemonics to ones and zeros, we require another component called as. So this assembler will take the target assembly code as the input. We try to generate a program which is almost ones and zeros. Still, it is not completely ones and zeros. Almost ones and zeros. Why? Because we have seen here that if the system is 32-bit configuration, it will generate assembly code for 32-bit configuration. If the system is 64-bit configuration system, it will generate the code for 64-bit configuration. Now, apart from the 64-bit configuration, we have to also take into account which operating system are we running on. Are we running on Windows or are we running on Linux or are we running on Unix? There are different types of operating systems, right? So based on the type of architecture of your system, it will try to generate a dependent object code. Assembly code is converted into object code now. So our first file name was prg.c. Now it has got converted into prg.obj. This is not completely ones and zeros. Do remember, it is some intermediary form which is almost ones and zeros. Why it is not converted directly into ones and zeros? Because it has to look into what is the system architecture of your underlying operating systems. Once it has generated for the underlying architecture of your system, this object code will be passed on to a component called as linker. What it will do is, it will try to see, apart from our program which we have written, the other operating system related files which are needed for this program to run. So it will try to link those additional libraries which our program to get executed on our operating system. Now, with those libraries and our operating system, our program coming together, this will be almost ones and zeros now. But still, these additional library files are to be compiled, right? This will be compiled here by the linker, create a program called as prg.exe. prg.exe is exactly ones and zeros which are required for this to execute it. prg.exe is completely system architecture dependent executable code. prg.exe is system architecture dependent executable code. Why do we call it as executable? We can double click this file and our program will run on our system directly. By computer can directly understand this particular program. Whereas if we try to double click this particular source code, computer cannot understand it. It will just open this prg.exe for us to view it and edit it. But it cannot be understood directly by the computer. Whereas prg.exe can be understood directly by the computer and can be executed by it. But when can it be executed? When there is proper memory available. So that allocation of memory will be done by another component called as loader. This loader will try to see whether system is free or not, whether the CPU on which we want to run our program is free or not, is there proper memory space available, how many variables have we defined in this memory space this program. All those calculations will be done. So this loader will load our program into memory space. And once this uh, loader loads our program in the memory space, the program is ready to be executed provided the CPU is free. Once the CPU is free, it will program inputs which are required for the program to be executed. So with this knowledge, let us proceed. I hope you have already done up with these things as the assignment. Now, let's quickly move on to this particular part. If you have understood that particular slide, it's very easy for you to understand our unit. Our C language program, arg.c, and assembly level language program, which the compiler has generated, target assembly, are called as C. These two are combinedly called as source code. Whereas the object code which we have generated, along with the object code, library files were needed. Along with the library files, executable prg.exe file was generated. This is the object code. Basically, bytecode is for Java language. I have kept it for you to introduce you. Bytecode is not completely exe format. It's not executable format. It is intermediary representation, just like our object code. So this object code and executable file or library file, these two combined together forms machine code. Object code and machine code becomes our object code in generality. So in C language, we don't have this particular bytecode. So what will be the remaining? Machine code. Machine code is nothing but our object code. Okay. Then what is executable code? Executable code is a code which is completely in the form of ones and zeros, which can be directly understood by the computer. Now let us try to see here. The source code file, which is high-level language program. The program may be C language program or C++ program. Both are languages for writing programs. We are learning here C language. So let us take a program called as hello.c. I have given the file name as hello. This will be passed on to compiler. The compiler will try to pick up our defined functionality along with previously defined functionality which we are using, which is there in preprocessor directives. It will try to pass it on by substituting the preprocessor code which we have used from the directives and generate a file called as hello.i. So our hello.c file, after substituting the preprocessor required functionalities, have become hello.i. This hello.i will be passed on to the compilation phase. The compilation phase will try to substitute or generate the assembly level, target assembly level code. This assembly level code will be stored in the form of hello.s. Hello.s. So let us begin. Our source code, which is in plain English. We will not define all the functionality. We will try to reuse some of the functionalities which are defined in preprocessor directives. So we have written hello.c. After substituting the preprocessor directives functionalities, it became hello.i. Now, hello.i has been converted by the compiler into target assembly code and stored in the file called as hello.s. This hello.s will be passed on to assembler so that the assembler can understand what is assembly level language and convert it into object code. This object code will be written in the form of hello.o. So hello.c got converted into hello.i, hello.i got converted into hello.s, and hello.s got converted into hello.o. Now this object code will be passed on to linker uh, or link editor, and it will try to pick up all the library files and it will try to generate hello.exe. Now once hello.exe has been generated, this is called as executable code, which is completely ones and zeros, also called as binary code. Okay, now binary code will be passed on to loader so that it can allocate some memory to it, and once the memory has been allocated, it will be given on to our RAM memory space to follow with our execution process. I hope this process is very clear for you people. Okay, again for simplicity I'm repeating, hello.c is getting converted into hello.i. Why it is getting converted? Because we have in our program, we have not defined all the functionalities. We have tried to reuse some of the functionality. So whatever we are trying to reuse some of the functionality which is already defined by other programmers, that code has become hello.i after substitution. Hello.i will get converted into assembly level language, which is stored in hello.s. This hello.s is converted by assembler into object code, which is stored in hello.o. This hello.o object code will be converted by the linker into hello.exe. Okay. So these are the conversion process. Now one small question. Do we need to do all this stuff? Do we need to convert it? No. You need not worry about anything. You just write your hello.c. You have brilliant softwares which will do all this stuff for you. From here onwards, till execution, you need not do anything. Just you need to type two commands and your work is done. It's plain and simple. You will open Turbo C3, which is one of the softwares compilers, which we generally call as. You will try to write your program in that compiler, hello.c, Turbo C3. And once you have written your program, save it with hello.c name. And after saving, just type two commands and the entire process will be done by the Turbo C3 for you. You need not worry for anything. Okay, but how it internally does it, how the Turbo C3 will do it, what are the internal phases, I have just put it in front of you so that you can have an understanding how your program is getting converted and what is going on in the background. Now, whatever we have discussed here has been again put into theoretical notes so that you can write it in your examination. This will come as an essay question. So, what is source code? It is nothing but a set of instructions written by some programmer, in language like C, C++, Java, or Python. It contains a set of instructions. Right? Instructions are nothing but the operations that are expected by the computer to be executed. For example, I want the computer to generate a mathematical table, right? Certain mathematical logic to calculate the mathematical table and display it on to the monitor. Now, along with this, today I'm writing the program. As I said, for any given problem, there may be multiple ways solutions coming up, right? There are multiple ways of solving it. Now, today I have that idea in my mind how I want to solve it. I have a strategy, but tomorrow I may not be there in the company, right? So, in order to make the computer program which I have written as a programmer to be more readable, to be more understandable by the next coming on persons, or in future, suppose today I have written and after 10 years I am seeing back the program. Will I be able to remember all those things, what I thought and wrote the program? Logical computations? No. So we'll apply certain comments. These comments make the program to be more understandable. But to remember, comments are not executed. They are not processed. Okay, they are just meant for our human beings, our programmers, to again understand that what was the programming steps or strategies which we have adopted. So our source code will contain not just the code for problem solving, it will also contain certain lines called as comments to make the program which we have written more understandable, to give an explanatory note to the instructions. So in short, we are talking about the source, and even substituting the preprocessor directives when it becomes hello.i, this is also called as source code. Coming on for assembly level code is a plain text, somewhat human readable, not completely human readable. Remember, we'll have mnemonics. Mnemonics are nicknames given to a sequence of ones and zeros, which were very commonly used. Okay, mostly has machine instructions. Let us see some of the instructions that are there. For example, if I want to multiply two numbers, I use a nickname called as mult. Instead of writing multiply, I will write MULT. It's remember, computer doesn't understand mult. That needs to be translated back into ones. So who will translate it? Assembler will take the assembly level language code as input, convert it into its corresponding executable code, .exe code. Okay, just like multiply, you can have add, ADD, you have for subtraction, SUB, for moving one value from one variable to another variable, you have MOV, for making a jump from one instruction to another instruction, you have got JMP. So by using these types of nicknames, which we call as mnemonics, we'll write the assembly code. Okay, so do we need to write it? No, we'll write our C language source code only. Compiler will do it internally for us. Okay, so CPU doesn't understand assembly level language code. This is very important for you to remember. CPU only and only understands ones and zeros, which is nothing but machine code or executable. To remember this part. So we are talking about assembly code over here, the entire process. Coming on for object code, this is a portion of your machine code. It is a complete program to remember, not yet a, it is not completely one. There are certain files which are required from the object. So we'll take up that particular. And this machine code is for a particular library. For example, if you are trying to execute a program, let us say, in a general perspective, let us say you are trying to use WhatsApp Messenger on your mobile. Think if you just have WhatsApp installed on your mobile, you'll be able to send the message from one device to another device, from one friend to another friend. No, you require internet also, Wi-Fi signaling also, right? If internet is not there, can you make use of WhatsApp? No. So what is internet? Internet is the internal software component of your Android or iOS machine. Okay. So unless and until you have those signals coming in, you will not be able to do with your work. Karthik, do you have any point to be raised? Karthik, you have raised your hand. Do you have any point over here to be made more?
No, sir.
Okay, fine. So whatever program we have written, it is just like WhatsApp. Along with this program, we require certain other components of the operating system to make our program to run. So whatever object code is there, it is a ones and zeros format code, but it is for a particular library or module. So we need to combine all those components and libraries to make our complete program. Okay. So this is the general description about object code. Since it is for one library, one module separately, it is containing placeholders so that the values can be substituted the remaining libraries or remaining modules. So who will try to do the substitution for the remaining libraries? Who will plug in the remaining libraries in the place? Linker. Linker will do that particular for us. Once Linker has substituted all the remaining libraries or modules for us, the entire code will be generated. Machine code. Okay. So from object code, we'll get machine code. We'll convert the object code into machine code. Linker. Linker will convert it. So linker will take the object code, convert it into executable code format by substituting all the object models or whatever relevant information is needed by our program to be complete. Okay. So what is machine code? Machine code or executable code or binary? Three names are same. It's nothing but a code which is containing only and only ones and zeros. And this can be directly executed by the CPU. If you have since you are having a machine code, if you open it, this is completely ones and zeros. You cannot understand anything. You cannot directly print it also. It requires further components to be, like for example, runtime objects to be in the loader has to load it in space and all that stuff is required. So in short, machine code is a binary code that can be executed directly by the computer. It contains only and only ones and zeros. Just that part. Okay. Now, you might have seen without you would have been forced to run the entire assembly level code, convert it corresponding object, convert the object code into executable code, all that stuff. We had to do it. Can we write the program in machine code? Can we write the program in assembly level code or object code? No. So we require a high level language which is similar to English language to write a program. Right? So what is procedural programming language? What do we mean by procedural here? Programming language we understood for writing a language used for writing a programming language. Procedural means in short, procedure is a step-by-step way of doing something. If what is the procedure to write your essay? You mean what do I need to write at the top, then the next line, then the next line, and then so forth? What I have to do. So same way, whenever you are trying to write a program, you are trying to solve a problem, basically. Now, while solving the problem, what is the procedure step-by-step format that you want to make to solve that problem? That's called as procedure actually. So C is a procedural programming language. This C will contain instructions which are executed first line, then the second line, then the third line, and so forth till the last line. That's why it is called as procedural programming. Who invented it? It was invented by in the year basically 1972. 1971 to 1972 was it. He was working on a project basically duration in the years 1971. He was working on a project called as Unix, Minix, MINIX, Minix. This Minix was an alternative to the Unix operating system which was existing at that time. At that particular moment of time, you did not have Microsoft uh, operating system like Windows 10 and so forth. And you had to purchase the operating system, Unix operating system, in a very high price. So what Dennis Ritchie was doing is, why to purchase it? Let's try to make a smaller version of it, which should be little cheaper to use. So he was working to make that particular software, which is basically a system programming software. And while doing it, he came up with the C language. Prior to C, there was a language called as B language. Now some may say, was there a language? No, it was ADA. So from ADA, they have taken A and generated the next language called as B language. From B, they developed C, and from C, they developed C++. So this funny stuff goes on in computers. So what Dennis Ritchie was doing, he was trying to mainly develop a system programming, right, operating system. While doing it, he came across development. What are the main features of C language? C is low-level access to memory. It gives us direct interaction with the memory of your run by using a concept in dynamic memory allocation. This pointers in dynamic memory allocation has given direct access to the system memory. That's why he was trying to make use of that C language to build up a system. This system programming language contains as you know, any language contains a set of words, right? So language contains a very simple set of keywords, and it is very clean to write, very neat to understand. Once I show you the actual example of a program, you'll come to know it's very simple. Okay, with these two main features, it became a booming industrial revolution to use C language. Earlier, there were B language, BCPL, ADA, and so basically he was trying to make generating a Unix type. This is the person who developed it, Dennis. You have to remember his name. It's a very important interview. So apart from those two features which are also important right, in our examinations, in the interviews also. First one is C program is a simple procedural structured approach, contains a rich set of predefined functionalities, which I have said you, which will be there in preprocessor. Those functionalities are called as library functions. Along with, if you want to make use of some memory, you have to define what type of is in that memory. So along with the data types. So C is a simple program. Second, it is machine independent or portable. You are not writing ones and zeros code. You are not writing object code. You are not writing assembly code. Who are generating all that stems? Compile. So you will write only and only C language code, which is plain English format code, and that will be computed or converted into the corresponding underlying system. Okay, so we call the C language code as machine independent or portable. If we can execute a program on multiple operating systems and multiple 32-bit or 64-bit computer configurations, we call that particular program as portable. Okay. Now, apart from that, and in normal English code, it can also contain some wordings which are similar to assembly level language also. That's why it is called as middle level programming level language. Remember, English code is getting converted into assembly code. High level is getting converted into assembly. So if you are having knowledge about assembly mnemonics, you can even use those mnemonics in C language. But it is very difficult and we will not usually use it. But C language is capable to understand that. That's why it is called as middle level programming language. I said C is a simple structured approach to solve a problem. Same way, it's a structure. We can break the entire program into parts by using functions. If you have got a bigger problem to solve up, you divide it into simple tasks and at the end combine all those tasks to solve. It's a rich set of libraries which are built-in functions which we'll use, which are defined in preprocessor directives. It gives us dynamic memory allocation and dynamic memory by using pointers. And it is at present moment of time fastest programming language which can exist in the arena. Any language that exists in the market. It is fastest in all the high-level languages in terms of execution. All other languages will take some time for getting executed, but this programming language is the fastest one. Okay. Now, just as I said, it gives us low-level memory access by using the same point here, which has been mentioned. Next, as I said, it contains a structured programming language, a task into smaller tasks. Sometimes the task is to be repeatedly executed by itself. Repeated execution of the same function by itself is called as recursion. So if we call a function from within the function, then that particular process facility is available. It will be very difficult for you to understand this concept now, but once we come across with programming part, we'll be able to understand what do we mean by that. Now C language is extensible. What do we mean by extensible? Extensible means if you want to add some more functionality, it contains a lot of inbuilt functions. If you want to add some more inbuilt functions, you want to define something, then you can define and add new features also. Now this is again an assignment for you. Let's then explain the importance of C language, which you have to do later on. I will tell you when you have to submit it. Now, what is the structure of C program? C programming is a difficult task for someone who is aware of basic structure of C program. It's simple if you understand what is the basic structure. If you don't know it, then it becomes difficult. Usually, many of the people, they will not try to understand the structure first. They will try to first write the. Yes, I know it's important to write the program first, but let us also have a look on the basic structure. Okay, how many things will be there in the C program? If we come to know, then we can understand it easily. So, basically, any given C program will contain at the maximum 7 parts. Maximum 7 parts. What are those 7 elements? First one is documentation section. This documentation section will contain a commit. As I said, source code will contain a description about what we are doing in the program. That section is called documentation section. It will contain comments. Now we are trying to reuse some of the functionalities which has been defined by earlier programmers. So it's called as preprocessor link section. So documentation section, we will have preprocessor or link section. You have to follow the sequence carefully. It will contain 7 parts, but you should not jumble them in between. Okay. Third section will contain definition section, wherein you will try to define those types of functions or variables which you want to use in your global declaration section. If you are trying to make use of particular variable or a used in more than one program, then you will have, or more than one task, then you will have the function declaration section, wherein you will define the list of functionalities to affect your programming. Okay. And lastly, one of the functions which you will write apart from is main function. Do remember, without main function, no C program exists. As a larger part, I can say there is no high-level programming language which will main function. From main function only, all other functions which we have here will be called one after the other. So main is just like the controller who will make a call to remaining functions which we have defined, function 1, function 2, function 3, for performing different tasks. Okay. So main will control all other functions. Internally, these functions will do the programming task for the functions we have declared here. We have just mentioned that we are going to write the code for these functions. We have to define them in the beginning. So these are the 7 sections which exist in any of the given C program. There cannot be any other. Okay. So first one is documentation section. Documentation section, you will have definition section. From the definition, you will have main function. From the main, you will have preprocessor. Here the sequence have been jumbled, but there is an error. Just I'll try to rectify it. Then we have got global section. Actually, main should come here. User defined functions and so forth. Now coming on for this documentation section, I have points what you have to write in your examination. Documentation section is going to contain, in simple terms, comments to make the program more interactive. These comments will talk about what is the program meant for, who is the author of the program, and at what date and time you are writing the program. So you can write any type of comments. Preprocessor directives will contain header files. These header files are the files in which already defined functionalities are stored. Suppose there is some already defined functionality for calculating square root of a given number. You can just make a call to that function and you can use that logic instead of writing the logic for calculating square root of a given number. So there are different mathematical computations to be done. So all those mathematical related functionalities have been stored in a header file called as max.h. Similarly, other header files are there. Suppose if you want to do input-output operations. So all those functionalities which are related to input-output functionalities have been plugged into one file called as stdio.h or common input-output.h, standard input-output.h or common input-output.h. So there are different header files which exist, but basically the header file contains the inbuilt functions which we are trying to use. So we have to include these header files in our program if we are using any of those functionalities. So next section is definition section. This definition section will contain the definition of variables which we are trying to use in our global declaration. If we are having some variables which we are trying to use in more than one functionality, then we will define them in global section so that it can be used in multiple functions. In function 1 and function 2 and function 3, I'm using a variable x. Now this x, if it is defined in function 1, it cannot be used in function 2 and function 3. It will not be known to these two functions. So in order to use it commonly among all the three, I will define them above it. So x will be declared in the global section. So next is a declaration of functions which we want to define. These functions are the simple tasks which we have used to solve our program in a major way. If we have a bigger task to be done, we'll divide it into task 1, task 2, task 3, so on, and each will be computed by a function. are the names of the functions that we are going to define and what are their syntaxes. So function prototype declaration section will contain the information about what functions we are trying to use, along with what are the names and data types and data. These are little complex terminologies. You'll come to know about it once we start writing our program. Next, main function. Program will be controlled by main function, which is nothing but execution uh, of your entire controlling mechanism on the execute beginning of our execution. User-defined functions, whatever functions we have declared here, those will be defined in this section. Defining means what they have to do, we will mention in this particular class. Here only we mention the name of the function and what are their inputs to be. How will it do how it will take the inputs and how it will perform the task and how it is going to generate the output will be mentioned user-defined sections. These are the 7 sections. Just excuse me for this particular wrong. I'll replace it out. And here is the simple program. As I said, comments will be the first section. You'll write the